Hello, welcome. Here we continue with our polynomials in chapter 9, and we are in chapter 9.4 now, multiplying binomials using FOIL. And as I have been eagerly anticipating this section, I'm glad that we are here because the FOIL method has actually been a method that I learned ever since I was in junior high and high school, and it has stuck with me ever since, and I don't think I will ever forget it. It has become a very useful and memorable tool that helps me. I think you will find this useful and easy to remember as well. First, we're going to take a look at some of these examples, and just to review here, okay, is each of the following a product of two binomials? Okay, so are we, in other words, in each of these products here, are we multiplying two binomials? No, because this is a monomial, this is a monomial. So no. Here, this is a monomial and this is a binomial. So nope. Here we have a binomial and a binomial. And yes, we do have a product of two binomials there. Here we have a binomial, but this one we have 1, 2, 3 terms. So we have a binomial times a trinomial. So no, that is not two binomials. Here we have two binomials, and here we have two binomials. So yes, this is a product of two binomials. Now, when we're multiplying binomials, the FOIL method is an easily remembered pattern for multiplying. Let's take, for example, we have a plus b times c plus d. The FOIL method means that I'm going to take my first terms and multiply them, a times c, the first terms, and then o is the outer terms, a times d. I means your inner terms, b and c, and then last terms means the last terms of the two binomials, b times d, and that is your FOIL method. So this becomes ac plus ad, the last term, or outside terms, inside terms bc, plus the last terms bd, right there. Let's take a look at an example here. Okay, let's say we have x plus 2 times x plus 6. If we use the FOIL method, the first terms will be x times x. The outer terms are going to be x times 6. So we have plus 6x. The inner terms are x, 2 and x here. So that becomes 2x. So it's plus 2x. And then the last terms are 2 and 6. 2 times 6 equals 12, right? So then that's going to be my last term right there. Then I simplify. 6x plus 2x gives me 8x. So now my final answer is x squared plus 8x plus 12. Simple enough, right? Okay, now let's take a look, try another example. Y plus 6 times the quantity 4y minus 9. My first term is y times 4y gives me 4y squared. The outer terms are y times negative 9 gives me negative 9y, so I subtract, okay, minus 9y. The inside terms are 6 times 4y gives me 24y, plus 24y right there. And then the last terms are 6 times negative 9 gives me negative 54, minus 54 right there. Then I need to simplify minus 9y plus 24y, and then I get plus 15y here, okay? And there's my final answer. Okay, now the FOIL method can be done mentally, but you just cannot forget to combine any of your like terms. And so far, the like terms that we've had are the x's, right? So don't forget to combine those. All right, let's do another example here. Okay, we've got 3a minus 5 times a plus 3. So my first terms, 3a times a, 3a squared. The outside terms, 3a times 3 is 9a. The inside terms are negative 5 times a gives me negative 5a. And the last terms are negative 5 times 3 gives me negative 15. So I combine the like terms right here in the middle, and I've got 3a squared plus 4a minus 15. And that's the final answer. Now, warning, be careful when squaring a binomial. Okay, so take a look at this here. A plus b, the quantity squared. This does not mean you distribute the square in through the parentheses. So this does not equal to a squared plus b squared. No, don't do that, okay? Don't do it. You still have to use the FOIL method to solve this correctly, okay? So that means when you have a binomial squared, you can go ahead and write it out. 2x minus 5, quantity squared, okay? 2x minus 5. And then you're going to multiply the first terms first. 2x squared times 2x gives us 4x squared, minus outside terms are 2x times 5, or negative 5. The inside terms are negative 5 times 2x gives us negative 10x. And the last terms are negative 5 times negative 5 gives me plus 25. And then I'm going to combine the like terms here, right? So 10x, negative 10x plus negative 10x. So I have 4x squared minus 20x plus 25. And there is my final answer. Now, let's take, for example, we have a word problem. And we're going to have to try to figure out these binomials based on the word problem. Okay, and it says the length and width of the pool, the swimming pool, can be represented by 2x and 3x. Okay, the length would be 2x and the width 3x. With the walkway, they become 2x plus 10 and 3x plus 10. So plus 10 would be the walkway. All right, that's the additional space to the length and the width. So now we want to find the area of this entire area, the pool plus the walkway. Okay, so how do we do that? You'll see the diagram actually in your book on page 386. Okay, so the area is your length times the width, but here's the new length, 2x plus 10, and then the new width, 3x plus 10. So we multiply just like we do with all the other binomials, and then you're going to start with the first terms. 2x times 3x gives me 6x squared, plus the outside terms, 2x times 10 gives me 20x. My inside terms are 10 times 3x. And then the last term, 10 times 10, gives me 100. And then I combine my x terms right here, and I get 6x squared plus 50x plus 100, and that gives me the area of the swimming pool plus the walkway. And then now you get to try these homework problems also, and notice actually there's only 10 problems or 11 problems, and they are toward the end of this chapter. Okay, the ones in section A are easy, and you'll get the same practice from section B anyway. So enjoy this assignment, and we'll be seeing you next time.